Okay, so now once we got the understanding about the data, now let's understand that what kind of problem we are trying to solve here. So we are interested in predicting about the class, right? So the class will be between 1 to 9. So it can be 1, 2, 3, 4, 5, 6, 7, 8, 9. And we have just got this value by looking at the unique values from the class column. Now, if you look at it, this is a discrete output, right? As soon as we see that it's a discrete output, we say that it's a classification problem. Now, the second question is it a binary classification problem? No, because in binary classification problem, we can have possibly only two outputs. And here we have more than two outputs. So this kind of thing is called as multi-class classification problem. So we are actually trying to solve a multi-class classification problem, and that's what the prediction model we are going to build here. Now, let's try to understand that from the real world perspective, what are the things really important for us while building our model. So what are the things we need to keep in mind while trying to build this model? So number one thing, so when we are trying to build this model, definitely it's a medical problem. Now in medical problems, the errors can be very costly. Imagine there's a patient coming to a doctor, and a doctor tells him up by looking at maybe his gene and the variant, well, basically mutation, and tell him that, okay, most likely you have this cancer, you are in this cancer stage or whatever. Now, and if his answer is wrong, that imagine what's gonna be the impact on that patient. He may even sue the doctor. So the errors are going to be very, very costly. So we cannot afford errors. We have to make sure that we do take care of that error component to bring it very low. So my accuracy is going to be highly important here. So in this case, we may want to return the result in terms of probability, because if you think about this, maybe we only want to give an answer in terms of yes to a patient, that yes, this looks like to be more appropriate answer here. So we may want to put a probability to it. Let's say if the probability of my answer that okay, most likely you are going to have this sort of cancer in, let's say, category 3, is, let's say, if I'm telling that with, let's say, 99% probability, I'm more confidently I can say that yeah, you have basically, let's say, type 1 or type 2 or type 3. So we can tell it like probability that you are falling into class 3, and basically given that you have x1 is your input, right? So x1 is nothing but you have your gene and you have your variance of this sort, or maybe the research paper for this variance is this, because we can easily get that research paper information from Google. So my gene and variance is this. So given this information, then if my, let's say, probability is coming out to be, let's say, 0.99, which is 99%, we can very confidently say that yes, you have possibly this sort of problem. But let's say if this is not coming out to be 0.99, but it is, let's say, 0. Maybe let's say 0.4 or 0.5 or 0.6, something like that, right? Now in this case, we are not really very confident on our answer, because if you look at the answer now, though this 0.5 may be a higher number in comparison to the other 8 classes, because maybe the other 8 classes might have 0.1, 0.02, 0.05, like this, which is contributing to the remaining probability. But still this number is ambiguous, or there is a possibility that maybe for if I look at this, maybe I'm getting a probability of basically y belonging to class 3, as where the input is x1 is 0.6. Maybe there's another probability of class 2, which is given this x1 coming out to be 0.4, and maybe the remaining all the probabilities are 0. So here also it's an ambiguity that where we should place it in, whether we should look forward for whether we can tell to the patient that you belong to class 3 category, or whether you belong to class 2 category. So maybe in this case we may want to look at more evidence to give some basically final solution to my client. So that's the reason I think the probability will be very important factor here. So in order to be more confident to avoid the error, we will be looking at our solution with respect to probability in this case. Okay. Now, one more thing which we can attach to build more confidence to is maybe telling the basically the reason. If my algorithm can even reason out this very well, that most likely if I'm telling to my patient that okay, you have class 3, then these are the evidence for it. I'm telling basically the reason that why I'm telling you that you belong to class 3. Maybe there may be few terms which I can use and say that okay, since you are falling with this thing, that's reason you are falling into class 3 category. So what does this mean? Means interpretability. Can my machine learning algorithm also tell that why it thinks that it belongs to class 3? So there are various algorithms which can help us in answering that. So there are few algorithms which basically tells those answers, and there are few algorithms which do not tell those answers also. So there are both sides of stories. We will see to that what are those algorithms which are good. For example, if I talk about your RBF, and basically I'm talking about SVM, this is highly non-interpretable. So if we have done a machine learning course, you might have learned it, but if not, we will go through some of the case studies and you can see that how it is not or how it is. And similarly, if I talk about a lot of other algorithms, for example, if I say naive Bayes, if we say decision tree, we say logistic regression, even linear SVM, right? So these are highly interpretable algorithms. These also can return you that if there is some sort of prediction happening, then why that prediction is making sense. So those sort of things also it can return. So it's very important for us to basically tell an interpretation of behind my prediction. That's is very important part which we want to also solve. Now, talking about the latency or time taken to return a result. Now, definitely, since I want to reduce the error, so maybe I can give some flexibility to the time part. My algorithm may take, if my algorithm is taking, let's say, a few seconds or few minutes to give an answer, I might be okay with that. Yeah, if my algorithm start taking maybe an hour, then it's might be an issue, right? Oh, sorry, one day, then it might be an issue, right? So it depends on my business requirement as well here. But most likely, I would be okay if my time taken by that algorithm is okay. Means if it is reasonably kind of manageable, I'm okay with that. Maybe like if you think about like companies like search engines, right? Internet companies like Google. Now, there basically the time is a very critical factor. If you say something, they want to immediately get an answer and give the output to you. The prediction algorithm required a very fast latency, should be very low. But here, I don't want my latency to be that low. It's okay if I take some time. So that's also one thing we can keep in mind while building models, because there are some machine learning algorithms which do take a lot of time when the data is huge, which you might have also learned during your course, like KNN algorithms and all that, which do take a lot of memory, which do take a lot of time. Basically, in terms of if you look at the order of complexity of those algorithms, it is high. But maybe in this case, in this particular kind of case study, maybe they fit quite well. We will see that if they really fit or not. But maybe if they take a little bit of extra time, I might be okay with that time frame. So that's also one thing which we have. And I have written all these points in detail for you to again go back and revise if you wish to. So these are the things which I just explained it to you. Now, it's highly recommended that before you start looking at this solution further, I have given you a detailed explanation about the problem, about a data set in machine learning, how it fits in terms of we are going to solve a multi-class classification problem. And even we understood that from the machine learning points, what are the important factors we need to keep in mind while solving this. So given all this knowledge, can you go ahead on your own and see that if you can come up with a solution on your own? I would highly recommend to pause it here. Don't go ahead and try to solve this now problem on your own, and later come back and start looking at the solution and enjoy it, right? So then you will realize that okay, what are the things you were missing out, and then you can anytime come back and look at the things and start working on that. So with this, best of luck for all of you who are solving this case study, for solving it first on your own and then match up a solution. Thank you.